Hello everyone, in this video we're going to have a look at the reverse process of differentiation of inverse trig functions. Now let's have a look at the first one. We have integration of 1 over square root of a squared minus x squared. Now you do remember when we differentiate the sine inverse or differentiation of the arc sine will give us this format here. So therefore we know the integration of this will go back to arc sine of x on a plus c. Now let's have a look at the second one. Now second one, the top has negative. We know that the differentiation of the arc cosine will give us this whole format here. So therefore when we integrate it, that will give us arc cos of x on a plus c. Now there's another way to write this integration. We can take this negative out. So therefore I have negative integration of 1 over square root of a squared minus x squared of dx. Now this is same as negative arc sine of x on a plus c. Now please remember this arc sine is actually same as the sine inverse. And in this video, I'm actually using arc sine, arc cos, and arc tangent a lot. Let's have number 3. The condition is a cannot be 0. Okay. Now, we remember the differentiation of the arc tangent or differentiation tangent inverse will give us this format. So therefore, integration of that will be arc tan of x on a plus c. Now we are going to use these 3 formulas to help us to integrate some special cases. The first question, we have 4 on square root of 9 minus x squared. Now the top number is the positive, and we have a square root, and we have something minus x squared. So probably the closest one is to the arc sine one, but it's not complete in that format yet, because for the arc sine, we must have 1 on the top. So what that means is we can take the 4 out. So that will give us 1 over square root. And remember for the differentiation of the arc sine will give us a squared under the square root. So we have to write 3 as 3 squared minus x squared. Therefore, the answer should be 4 arc sine is x over a. So 3 is your a, and you have x over 3 plus c. Now let's have a look at question B. We have integration of 7 on square root of 3 minus x squared. Very similar to question A, so we're going to actually follow the similar steps. So firstly, we want to make the numerator 1, so that means I need to take the 7 out. And square root, that 3 has to be a perfect square. So we know that square root of 3 squared will give us 3 minus x squared of dx. Now your a is square root 3. So therefore, again, this is arc sine, so it's 7 arc sine of x over a, which is root 3 plus c. Now again, this is actually same as sine inverse of x on root 3 plus c. Now obviously you can actually rationalize this. So you have 3 root 3 on 3x. So you can rewrite it as 7 arc sine of root 3 on 3x plus c, or you can use sine inverse as well. Now question C, you have negative sign on the numerator. And then the denominator has a square root, and you have something take away x squared. So immediately, it looks more like integration of negative 1 over square root of a squared minus x squared. So I'm thinking about arc cos. So it's negative 7, but I do want to have negative 1 on the top. So that means I'm going to take 7 out. And square root of 4, I'm going to write it as a perfect square. So it's 2 squared minus x squared of dx. Now my a is 2 this time, so I can use arc cos. So therefore the answer is 7 arc cos of x on a, which is 2 plus c. Obviously, you can also write it as 7 cos inverse of x on 2 plus c. Now let's have a look at question D. So question D, we have negative 7 on square root of 1 minus 4x squared. Now pay attention this time. We do not have x squared alone, we have 4x, but we have to have x squared only. So what we are going to do is we're going to factorize it. So let's have a look at this one. So firstly, let's take the 7 out. So we have negative 1 on the top. Now, square root. So I do not have 4 attached to x squared. So I'm going to factorize the 4 out. And 4 times a quarter will give us 1. So therefore, it has to be a quarter. And take away x squared. So by factorizing it, now we have x squared. So let's continue. So bottom one is actually same as square root of 4 times by square root of a quarter minus x squared of dx. And square root of 4 equals to 2. So again, I can take this 2 out of the integration. So that is actually because in the denominator, so it's same as half. So we have 7 on 2 integration of negative 1 over, we only have the square root of that whole thing left here, but we can rewrite a quarter as half squared minus x squared of dx. Now you have your a, which is half. Now we can rewrite everything as 7 on 2, and this is arc cos of x on half plus c. And let's tidy up again. So it's 7 on 2 arc cos 2x plus c. So for this question, the key is really we need to factorize this 4 out so that we make sure that we have x squared alone. And then continuously we can take the constant multipliers out of the integration. Now let's have a look at these two questions, but what I would love you to do is to pause the video and try it by yourself and come back to check your answers. Question E. We have integration 1 on 16 plus x squared. Now if you notice that there's no square root and there's a plus in between. So that's actually the hint that we're going to use arctangent. So in order to use arctangent, remember it should be in the format of integration of a over a squared plus x squared of dx. Now you realize it, yes, I can change this 16 to 4 squared plus x squared, which tells me that my a should be 4. However, my numerator is not 4. So in order to have 4 as a numerator, what I need to do is times by 4 to the numerator. However, whatever I do to the numerator, I need to do the same thing to the denominator as well. So that's why I'm actually multiplying by 4 on 4. So now I have 4 over 4 squared plus x squared times by a quarter of dx. Now I can take this a quarter out of the integration. So therefore it's a quarter integration 4 over 4 squared plus x squared of dx. So now I can say this is a quarter arctan of x on 4 plus c. Now question F again is actually using the arctan. Now you need to have a on the top and you need to have a squared plus x squared for a denominator. However, here we don't have x squared, we have 5x squared. So we are going to factorize the 5 out first. So we have integration of 1 over 5. And in order to get 7, we must have 7 on 5. So when you expand the bracket, that will give us 7 plus x squared of dx. Now, we can take 1/5 out of the integration. That will give us 1 over 7 on 5 plus x squared of dx. That's great. Now we have x squared alone. Now we are going to rewrite 7 on 5 as something squared. So that should be square root of 7 on 5 squared plus x squared on dx. Now the next step is we need to make sure the numerator has a. For this case, the a is root 7 of 7 on 5. So what that means now is I'm going to multiply root 7 on 5 to the numerator as well as the denominator. So I'm going to times by root 7 on 5 and root 7 on 5. Now, therefore, now I have root 7 on 5 on the top, and I have root 7 on 5 squared plus x squared. We can take this out as a constant. So that will be 1 over 5 times by root 7 on 5. And the whole integration is arctan of x over root 7 on 5 plus c. Now let's tidy up the surds. So start with this one here, 1 over 5 times by root 7 on 5. So the bottom one, you can rewrite it as root 7, 5 root 7 on root 5. So because it's 1 over fraction, so we can actually flip it. So it becomes 5 on root 5 on 5 root 7. So we multiply by root 7, both top and the bottom. That will give us root 35, and 5 times 7 is 35. Now let's deal with the x on root of 7 on 5. So this can be rewritten as root 7 on root 5. So therefore, again, flip the fraction. So you have root 5 on root 7 of x. So rationalize. So you have root 5 on root 7 times by root 7 on root 7 of x. So that will give us 7 for denominator and root 35 as numerator. So now we can rewrite the answer. So that will become root 35 on 35 arctan of root 35 on 7 x plus c.